Hello, everyone. I think I know a lot of people in the room, but if we haven't met already, my name is William Woodruff, and I'm here today to talk about the next 5 years of supply chain security on PyPI. So, it's a quick introduction. Like I said, my name is William. I work at a company called Trail of Bits. If you don't know us, we're a roughly 130-person cybersecurity consultancy. We have a lot of different specialties, but a lot of people know us primarily for cryptography consulting, compilers, program analysis work, as well as supply chain and general open source contributions. I'm happy to talk about those in person or if you have questions after the talk. Before I do any actual content within this talk, I wanted to do some shout outs. We've been working on various parts of PyPI and Python packaging security for the last 6 or so years within Trail of Bits, and that work has been funded by a variety of entities, some of whom are in this room. So I specifically wanted to shout out the Google open source security team for funding a lot of this work, especially a lot of the details I'll be talking about today. But also some of it's been funded directly by the PSF, the Python Software Foundation themselves, and the Sovereign Tech Agency, which was previously known as the Sovereign Tech Fund. And I want to give a special shout out to Dustin Ingram and Hayden Blosver in particular for their vision around SigStore and then Python security more generally. To set a rough agenda for what I want to talk about, I know not everybody in the room is necessarily familiar with the ins and outs of Python packaging and PyPI specifically, so I wanted to give a brief mode set on that. Then I wanted to talk a little bit about how we think about systematically securing Python packaging. And what that boils down to is treating the problem of security first and foremost as a usability problem within Python packaging because of how big and diverse the Python packaging and Python community as a whole is. I then wanted to do a quick recap of previous efforts over the last 26 years of Python packaging's history, talk about the last 5 years of what we've done, including current and ongoing efforts, and then finally the actual sort of meat of the talk, which is the next 5 years, which, as an important disclaimer, I'm not a maintainer of PyPI. I maintain things adjacent to PyPI, but not the index itself. And so these are my opinions as an outsider who's done a lot of work in the space, but they don't necessarily reflect the opinions of the PSF or PyPI's admins or the PyPA or any of these other groups. This is just what I think we can do in the next 5 years. So with that in mind, I'll do some background. PyPI itself is the Python package index. Importantly, it's pronounced PyPI. That's not PyP or PyPI or anything. It's PyPI. I will correct you if you say PyPI to me. Most people don't interact with it directly unless you're a Python packager yourself. You know it as the thing behind pip install. So as an end user, when you run pip install, by default, what you're hitting is the Python package index. If you take nothing about the index away other than this, you should know that it's very large in terms of what it hosts and the volume of stuff that it serves every day. It has about 860,000 users as of last week, 500,000 projects, 6 million releases within those projects, and then 12 million files within those releases. And the reason for that discrepancy is because a release within Python, such as a version, has multiple files, which can be a source distribution or a binary distribution for a specific platform. And so many packages host 2 or more files per release to optimize downloads for specifically Linux x86-64 or Mac ARM, etc. So that's why you see that factor there. And this translates roughly to about 51 billion downloads a month or 2 terabytes of traffic per day. This, of course, is somewhat inflated by things like CI/CD and tools that eagerly download the same file over and over again instead of caching them. But it should reflect sort of the extreme demand for Python packages. And this is still growing at like a factor of about 20% a year, last time I checked. So I pulled this last month, but next year it'll be 20% larger, roughly. Sort of a larger context, PyPI is just one small part of the Python packaging constellation community of tools and standards. There's things I mentioned before, like pip, which are sort of the installer surface that most people interact with. That's things like pip, UV, poetry, PDM. But there's also these build tools and backends, the things that actually produce Python packages. Many people know setup tools. Some people know hat, flit, poetry again. These actually are what under the hood construct source distributions and binary distributions, those files I talked about. Then there's upload tools like Twine and UV, again, poetry. But the key thing to notice here is that while some tools cut across all of these feature surfaces, very few do everything all at once. And this reflects a larger important fact about Python packaging and therefore how we approach security in Python packaging, which is that Python packaging is not one tool driven. It is a standards and community driven community in which primarily consensus is achieved through these things that we call PEPs, Python Enhancement Proposals, which then become more acronyms, PyPI living standards, which are then adopted by individual tools so that all the tools interoperate together. And this, hopefully for obvious reasons, becomes important later because it shows that we can't induce things by just adding them to, there's no Python equivalent of cargo. You can't just add a feature in one place and have everybody adopt it. Instead, you have to work with each tool and each part of the constellation to incrementally improve the security of the overall ecosystem. And perhaps not surprisingly from that, Python's community is massive and diverse. Every possible combination you can think of for developers, data scientists, non-programmer researchers, journalists, are using Python and running pip itself every single day. And this makes it pretty hard to establish a common denominator for experience or security awareness or anything of that sort. And the way that I like to think about it is that Python more closely resembles a country in terms of breadth of interests and experience than it does a community like Rust or C or C++. And this, again, plays an important role in how we think about securing this massive community. Yeah, so with that, so Python, it's by some metrics the world's most popular programming language, and a huge part of that is its diversity of users, which is both a huge strength in terms of it brings a lot of interest to the community. It brings a lot of huge separate columns of stacks. So we have data scientists, we have AI people, we have health, fintech, et cetera, all using it. But this also represents a huge risk to systematic security changes. In one way, it makes systematic security planning like a self-fulfilling, the failure of systematic planning a self-fulfilling prophecy, because you need to accommodate existing conventions, which means you have this N+1 standards problem, where you try to do a thing, you add a new security standard, and everybody just sort of accretes it onto their existing insecure stuff. So now you have insecure plus secure, which is just insecure. And it can also be more sort of abstractly dangerous to the things that keep Python's community healthy. If you start establishing onerous security requirements on novice users, people who are being told by their professors to upload their first package to the index, those users are scared away when they actually want to become professional Python developers. So we have this hard balance to make, hard balance to establish or maintain, which is we want to secure this ecosystem, but we also don't want to scare away people whose day job isn't actually programming. They're just using Python because it is the tool for their job. And so this comes down to my core point, which is, especially in the context of Python packaging, we treat security, or at least I treat security, as a usability problem first and foremost. In order to bring security to this huge demographic of people, or this huge population of people who don't necessarily have any prior interest in it, we need to first give them a carrot of things to do, which can then lead them to a more secure posture by default. And to break this down a little bit more, we think about really two core demographics within Python and Python packaging more specifically. There's this enthusiast demographic who are 1 to 5% of all Python publishers and consumers. And those people are enthusiasts about Python itself. They believe in the future of the language and the ecosystem. And so they are often more willing to adopt security features, even if those things are a neutral or even slight negative change in their usability posture. And then there's everybody else, which is the 95 to 99% who only care about the reliability of their workflow, which in practice means that pip install must never fail. If pip install begins to fail for them when it worked the day before, they just do something else. Or they complain and stay on old versions and they accrete vulnerabilities that way. And so there's good and bad news for these. The good news for that enthusiast demographic is that most of the top packages by download are maintained by this demographic. So things like URL lib3, cryptography, professional teams at AWS and Google maintaining SDKs. That demographic has either because they're already invested in the community as a whole, they have the willingness that they have to make changes has a huge disproportionate impact on the larger ecosystem. However, the bad news is that there's still an overall tiny minority of package maintainers, even if they represent 90% of all downloads. And then the good news for everyone else is that if we make things easier for this larger demographic, then they will happily adopt these changes. Sometimes they'll even adopt it by default without realizing what they're doing. And that's the real goal. So with that in mind, I want to talk about some previous efforts and successes and failures around them. So with that, we have to go way back in time to the early history of Python packaging. So I've cut off another even earlier history here, which is trace Python packaging all the way back to the late 90s in terms of sort of when this stuff begins to get standardized. But the key thing, at least for this narrative, is PyPI comes into existence as an index in around 2003. But it was an index. It didn't actually begin to host files themselves, the things that users actually download, until 2005. What it was before was you would go to PyPI and you would get an HTML page of all the projects that were in the ecosystem, which was like a few hundred projects, and you would click on that link and it would take you to another website, and then you would go and manually download that distribution, build it locally, and accrete it into your stack. So it was HTTP plus HTTP redirects to random servers, which is great. So about a decade later, around 2013, PyPI adds HTTPS. It was quickly made mandatory for web users and was made the default for pip and easy install. Easy install was the sort of predecessor to pip for package downloads without having to actually manually navigate to the index. Yeah, 2 years later, this is sort of when Python packaging sort of takes off really as a standards process. PEP 503, again, Python enhancement proposal, standardizes the index API. So the thing that pip and easy install were pulling from was previously unstandardized. This locks it down and says other clients can begin to build off of this as a fixed format that you can rely on. And critically, this index API begins to include digests. So now you can actually check that the index claims the integrity of the file is this one thing, and if it doesn't match, well, maybe someone modified it, or the third model there's a little bit murky because you're still trusting the index, but now at least there's actual digests on the index. And around the same time in 2015, PEP 470 formally deprecates this link to another server approach and removes the remaining external links. So at this point, PyPI becomes 100% self-file hosted, a self-hosted index. 2 years after that, PyPI is rewritten from what we call legacy PyPI to the new current code base, which is Warehouse, and that current backend went live in 2018. So that's where everything sort of really rockets, because the legacy code base was pretty hard to work with. So after that, a whole litany of things happened. So in 2019, PyPI implements and enables multi-factor auth in the form of TOTP and WebAuthn, so for physical tokens. So when you log in now, you type your token or you type in your TOTP code. Same year, API tokens are added. And this is really key, because before that, to upload to PyPI, you would put your username and password into Twine or your other upload client, and it would just basically do, it would use that as your permanent credential everywhere, which, as we all know, permanent user-controlled credentials with no scoping are a good idea. So in 2019, we had scoped API tokens, which complement username and password, so we didn't disable that yet. However, as I mentioned, 4 years later, we end up disabling that. In 2020, we initially attempted to implement TOFU via PEP 458, as well as do malware detection and scanning. I'm happy to talk about some of the details about why these ultimately were disabled or not fully rolled out, but as another part of the core, like the code base itself rapidly accelerated at this point. And then in 2022, there was an initial critical rollout for MFA, meaning that projects over, I think, 10 million downloads a month were required to enable MFA, and WebAuthn physical keys were given out for free to those critical projects. 2023, this is the actually kind of important part of this talk. We implemented trusted publishing on PyPI, which is this credentialless authentication method where you can connect to your CI/CD provider like GitHub Actions to the index, and they will exchange credentials for you so that you don't have to manually scope and potentially lose your API token. This complements the manual API token flow. And then finally, just this year, January 1st, multi-factor is made mandatory for all PyPI projects. So the critical designator is removed. All projects now have to use MFA, which in turn also makes API tokens fully mandatory, meaning you can no longer upload with a username and password. You can, of course, still log in with it, but you can't upload with it. So that's a whirlwind tour of what's happened over the last 5 years. Now I want to talk a little bit about what's currently going on. So I want to start with kind of a small thing, which is verified project URLs. So a surprising number of people, at least to me, go to pypi.org, go to a project's page, and they'll look at the metadata and say, well, the metadata says this project comes from github.com/google/thing-I-trust, and therefore I'm going to download and use this package. And again, this is a testament to how diverse and how large the Python community is. They don't realize that metadata isn't actually verified. It's just whatever the package claims it comes from. And so we had this repeated series of issues where people were like, oh, well, I have this package on PyPI that says it came from Amazon or Google or someone else, but really when I download it, it's malware or just junk that someone like copy-pasted from a template from Google. So what we did was we added verified project URLs. And I can talk a lot about the internals of this, but the core of it is that it was built off of the trusted publishing feature. Because trusted publishing knows the CI/CD identity it came from, we can then verify github.com, gitlab.com, et cetera URLs based on that trusted identity. And this makes it harder for typo squatters as well as honest, innocent mistakes to occur around submitting a project that has malicious but valid-looking links. And this is sometimes called starjacking, which I think is like the worst possible name for a vulnerability class. But then I want to talk about the bigger thing, which is attestations. So this comes in the context of trusted publishing. Trusted publishing was a huge success on PyPI. Over the last year, we've had 20,000 projects enroll, which is disproportionately newer projects, which is fantastic. And those projects have collectively published around 500,000 files using trusted publishing. One of the reasons why it was a huge success was because it was a usability win. Users no longer had to manually create API tokens. They could just register their GitHub account or the GitHub repo, and they would automatically have tokens minted for them from GitHub Actions and GitLab CI/CD, et cetera. So we took this default flow, which made things usable by default to make them more secure, and we applied that to attestations as well. So there's this entire standard, PEP 740, which basically says, here's how to generate an attestation using the identity that you know from trusted publishing. And so what we do is when a user does a trusted publishing flow via GitHub Actions, for example, we'll take that OIDC credential that is used to exchange for an API token, and we'll also create an attestation that says, this Python package distribution definitely came from this GitHub repo at this time. And we build this all on top of Sigstore because Sigstore is the right substrate for binding OIDC credentials to short-lived signing keys. So no long-term signing keys, only machine identities, and this is live on PyPI as of last month. Wow, that's completely unreadable. Okay, I'm going to skip these. This is a diagram of the flow for trusted publishing plus attestations. The key thing to know, which I know you can't see, is that on the far right, the entity is Sigstore. And the core thing to observe is that the flows are only between Sigstore and GitHub, meaning that there's no additional configuration or interaction needed to go from trusted publishing to attestations, which means that it's on by default for users. Users don't have to do a single thing besides upgrade to the latest version of their publishing workflow to get attestations on PyPI. So what does this actually get us? I mean, the main thing, at least in my mind, the main thing it gets us is publicly verifiable proof of a Python package's provenance, which I actually had to say that a bunch of times to make sure I didn't over-alliterate on it. It's equivalent to the English sentence, a package named this thing, foo, of this version 123, was produced by a GitHub repository of this slug via this workflow at this commit. And previously, you could claim this to PyPI via trusted publishing, but a user couldn't externally verify it without trusting PyPI to then serve honestly that metadata. Now with attestations, the user can pull down that attestation and confirm, in fact, that a package was produced by a specific machine identity at a specific time, at a specific commit, et cetera. And this comes with key external transparency and auditability properties. Each attestation, because it's all based on Sigstore, has a corresponding transparency log entry, which a user can then audit for context. And of course, because this is all based on machine identities, you can proactively monitor for your machine identity. So if you are Google, for example, you could monitor for all publishing activity from github.com/Google and see, did someone publish to PyPI a distribution that you didn't expect, for example. I'm going to talk more about why this isn't a perfect end user story in the next 5 years part. But the key part about this is it changes the game theory for an attacker. It makes it harder for an attacker to get away with compromising a package or its repository. It makes it riskier for them. And so the idea is to both make it easier to detect them, but also the goal is to incentivize them away from this kind of attack. However, this is itself not perfect, and I'll talk about this more in the 5-year section, because attestations aren't and can't be made mandatory. At the end of the day, we still have a huge number of packages on PyPI that publish via manual API tokens. And for those users, Twine upload still needs to work, and we can't begin to fail those workflows because we break in a huge amount of the Python ecosystem. So I have some thoughts on how we can make this a more blanket property, but that's for later as well. So how are we actually doing so far on attestation adoption? So the cool thing here is it's only been about 2 weeks since we enabled this feature, and already we have about 10,000 attestations uploaded on PyPI since enablement. And if you go to this QR code, this takes you to a website that we built to track the top 360 packages and their attestation support. So I screenshotted this, I think, 2 days ago. As of 2 days ago, 5% of the top projects have attestations uploaded. But a key confounding factor here is that 2/3 of all packages haven't been uploaded since attestations were enabled. So in reality, it's about 10% of top projects uploaded since enablement, which, that's not a large number, but it's also, in my opinion, not bad considering it's only been 2 weeks. So I'm pretty happy with this. And we expect this to go up over the coming weeks because we know for a fact that URL lib3 requests, et cetera, all have attestations enabled. They just haven't made releases yet. And so when those are done, I expect roughly about 30 or 40% of the top 360 packages will have attestations enabled, which I consider a win. Okay, now I want to talk about the next 5 years of supply chain security. And if you take nothing else away from this section, please understand that I want lockfiles in Python because it makes everything else that I want to do much, much, much easier. So one big thing is extending attestations. So as I talked about, we have this standard PEP 740, which defines how to bootstrap attestations on top of trusted publishing. What this means is that we've intentionally, for the purpose of tractability, limited the scope of attestation support in PyPI for the time being. They're intentionally limited to just trusted publishers that sign identities. However, there is no conceptual reason why this has to be the case. PyPI also has a notion of a verified email identity, because when you create an account on PyPI, you put in an email address, and PyPI sends you an email challenge for that address. Given that, we can also enable email signing events through SigStore and allow them via the traditional Twine upload path with an API token. So that is something that we're actively thinking about as a way to broaden the applicability of attestations to a larger user base. On a related subject, we want more attestation types. So right now, PEP 740 stipulates 2 attestations. It stipulates SALSA attestations and what we call publish attestations, which are really just a commitment by the publishing workflow, such as Twine, that it in fact published this distribution to PyPI. Confusingly, it's the exact opposite of a publish attestation on NPM. It's what they call a release attestation. But we can also add more attestation types. There are VSAs as well as third-party attestations. So for example, if you're a third-party security company or supply chain company, and you want to be able to say to PyPI, I reviewed this package, we can potentially enable you to upload an attestation that says, requests version this was verified by this security company to have these properties. And so that's the kind of thing that we want to unlock in the future. So goal 1 is expand the breadth and depth of the attestations that are meaningful to PyPI. Next thing, this is the hard truth about all this stuff. It's one thing to sign, it's one thing to generate attestations and put them on the index and like show users pretty green badges. But that's the easy part, relatively speaking. It's relatively easy to put cryptographic materials on the internet. The much harder part is actually getting people to verify those materials. So what we've done for the time being is PyPI itself verifies attestations on upload. The reason it can do that is because they're tied to trusted publishing identities. But getting user agents, such as pip and UV, to verify them is much, much harder. And there are both architectural and standards constraints for why this is. The main architectural one is that tools like pip, especially pip, because pip is baked into CPython as part of the distribution, it needs to have pure Python dependencies. Everything that pip uses gets vendored into the code base during packaging. However, SigStore Python uses Python cryptography, which itself is mostly Rust under the hood. And so by default, we cannot use SigStore Python within pip, within like a default flow, because pip simply cannot depend on SigStore Python. But even apart from this, there are standards and tooling limitations, which goes back to my pipe dream about lockfiles. The lack of a standard lockfile format in Python means that TOFU verification, where we first download, we lock the identities expected with packages, and then on each subsequent upgrade, check that those identities haven't diverged. That isn't currently possible with the current Python packaging file standards. We first need to establish that kind of lock file so that we can lock expected signing identities and then see what happens when they change. So goal 2, and this is a pretty big goal because it has a lot of moving parts, is actually bring this attestation verification not just to PyPI where it already exists, but actually down to downstream users, so that when you do pip install, you implicitly lock and then verify subsequent upgrades. Getting like sort of even bigger picture. As I mentioned before, attestations are really powerful and we want to expand their scope, but fundamentally they are limited. No matter what we do, there's still going to be this huge tail of Python packages that cannot or will not generate attestations for their packages. These are because they have manual API tokens or because they have processes internally that just simply do not enable some sort of like public attestation of a form that we can consume. And also, just not everybody uses trusted publishing, and this is fine. That's a perfectly intended, secure setup for using PyPI. But as a result of this, it's de facto impossible to do index-wide monitoring with just attestations, because there's an unbounded number of signed identities, and also some packages that simply won't have signed identities whatsoever. And then, more generally, because PyPI is still trusted to serve those attestations, you still have this sort of degree of faith in PyPI itself, which we want to not eliminate because PyPI is unsafe, but because the goal of all this stuff is to reduce unnecessary trust in the ecosystem and ensure that we can verify everything that we do in fact trust. So what we really want is blanket transparency and authenticity properties, which means binary transparency for PyPI. There's a bit of prior art for this out there. Go's sumdb is probably the most successful and well-known example of a binary transparency scheme for packaging ecosystem. But there's also NPM's published attestations, which, like I said, are the opposite of PyPIs. And these are cool because they are a blanket signing event done by the index itself. These also come with a variety of desirable client-side properties. A key one is that, unlike Sigstore, where you need to have an X509 stack to verify certificates, when you're verifying the inclusion proof from a transparency log, a binary transparency log, all you need is n ECC signature verifications, one for the log itself and for witnesses, as well as the actual Merkle math for the inclusion proof. However, this also has significant downsides, which I think could use the insight and thought of everybody in this room, mainly that monitoring and witnessing are still open questions from a design perspective. And so if you have thoughts about how we can achieve these things, given that this is a 5-year plan for us, I would love to hear them. So to cap, goal 3 is index level transparency for PyPI. Okay, so then I want to summarize. So this is the dream. So today we have misuse-resistant credentials on PyPI and opportunistic on-by-default publish attestations, thanks to the work last year on trusted publishing and the work this year on Sigstore-based index attestations via PEP 740. But this doesn't go far enough. Tomorrow, we want downstream attestation by user agents, meaning pip, of those attestations. It's possible today, but not without significant architectural changes to these things. So we need help with that. We also want upstream, meaning maintainer, monitoring of publishing identities. We want companies like Google and Amazon, but also large independent maintainers to be monitoring their expected GitHub, GitLab, et cetera, machine identities and seeing when events occur on the public transparency log corresponding to those identities. That will help us establish a baseline for what's expected around monitoring in this ecosystem. And then finally, as sort of the biggest item, is we want index level transparency with a healthy witnessing network to enforce the honesty of that transparency log. And these are done in order of design thought that's needed. And so we could use your help thinking about this and how we want to achieve this in the Python packaging ecosystem. And then to summarize this all as one big sentence, which is what I like to do, I want to be able to express a sentence like this. When I download some project with some version from the index, I know that it came from the repository it's supposed to come from, meaning that when I lock that identity, it does not change. And that PyPI served the exact same file to me that it served to everybody else. Meaning that even if somehow someone compromises that machine identity, they have to compromise everyone at once, fundamentally changing the game theory for them into a high-risk attack versus a low-risk targeted attack. That is the dream. Well, that's the check marks. That's where we are. We're working on that, and we are nowhere near that yet. So that's what we need help with. That's it. These slides will be available online. I think that link, I don't know what that takes you to. Slides are there. These are some resources you should check out. If you go to docs.pypi.org, the headings will take you to the various pages if you don't want to type those in manually. And then I'm happy to talk in person as well as online. You can find me on Mastodon, and that's my email. Thank you very much. I don't know if I have time for questions.
Yeah, I think we have a couple minutes. Any questions?
I'm a big fan of trusted publishing. What do you do when a project was using trusted publishing on PyPI and then they stop or their identity changes?
Yeah, that's a great question. So on PyPI, a trusted publisher is registered to the project itself. So when you delete a trusted publisher, subsequent releases can no longer be attested with that publisher. So essentially what we'll do, and this is part of the changes that will be hopefully public in the next few days on the UI itself. If you upload a release with an attestation, we'll give you a check mark for that release. But if you then delete that publisher, subsequent releases will not be given that check mark. However, previous ones will, because we previously verified that. So it's stateful. It's tied to exactly when the publisher was registered. Hey, James.
You said that, I guess, getting client verification in pip was difficult due to requiring Python only.
Mm-hmm.
It has to be Python. What are the challenges there? It sounds like easy to do in Rust, not easy to do in Python.
Yeah, the main thing is there's a lot of things under the hood in 6-door Python that are, so 6-door Python implies an entire X509 stack. And so if we wanted to do this in pure Python, we would need an X509 stack in pure Python. Those exist, but they're not super well maintained. And so I personally would prefer not to re-implement X509 yet again. We're using Python cryptography, which I'm very happy, and I would not want to change that. Yeah.
So you mentioned or talked about the difficulty of integrating this into pip or the installer clients. But apart from that, do you see the kind of low-hanging fruit that basically what's the thing that you would like to see someone outside of PyPI to implement to kind of use this?
Yeah. So the low-hanging fruit for this, there's two that I can think of. One is that because Python packaging is huge, we're aware that there's a lot of companies and internal consumers of Python packages that have bespoke build systems or consumption systems. And so if there's anybody in this room who has a Python stack internally where you pull down distributions manually and do stuff to them, today you can hook attestations into your verification pipeline around where you hopefully check digests. So if you're already checking digests, just put another step there. That's one place. And the other is, I think I might have alluded to it, but we are looking at a plugin architecture for pip. So one idea that we have is we're working with the pip maintainers to expose hooks into pip. And so we'll be able to hook into the install phase. And every time someone tries to fetch a distribution from PyPI, we will then check if that distribution has an attestation, maintain a sidecar lock state, and check and verify the attestation. And this will bypass the native dependency requirement because you can then pip install the plugin, which is a bootstrap issue, but at the very least, it'll be a proof of concept.
All right, any more questions?
Cool. Thank you.
All right, let's give our speaker another round of applause.